Okay, so this video is on implicit differentiation, and it's the last of the differentiation techniques. So we have our power rule, we have our product rule, we have our quotient rule, we have chain rule, and then implicit. And the rest of them are just kind of your trig rule and your exponential logs, but those are more just knowing them. This is the last one that's going to help us to differentiate functions. So the big question here is, why do we need another one? We have so many, and this is a perfect example of why we need one more rule. So if you look at this one right here, and I said, okay, take the derivative, most of you would probably try to isolate the y right there. And I'm going to tell you right now, because I don't want this video to go on forever, it's impossible. You cannot get this into just a y equals form. So what implicit differentiation allows us to do is to take a derivative as the function is. And actually, you've been doing this all along, because if you remember, we've had things like y equals x squared. That would be a typical derivative that we've already taken. And then you guys would write this as maybe y prime equals 2x, or we've seen the notation dy dx equals 2x. So either one of those are the same, but you really just took an implicit differentiation, because all you're doing is taking the derivative of y with respect to x, and that's the implicit part. So let's see how this works. For instance, if you have this circle right here. So find the slope of the circle. Now this one, you could isolate that y there. It's not that difficult. You would subtract over the x squared. You would square root plus or minus, and you've got your derivative, or you're able to isolate the y and then take the derivative. But I'm just going to go ahead and start taking the derivative. So the derivative of x squared is 2x. The derivative of y squared is 2y. But here's the difference. Whenever you take the derivative of a variable other than the one you're taking the derivative with respect to, in this case, we're taking the derivative with respect to x, you need to tack on a dy dx, or a dy dt, or a dc dt, or whatever it is. So whatever the variable is over dx. So you take the derivative like normal, but you tack on the d whatever, and then d whatever you're taking the derivative with respect to. And then the derivative of 25 is 0. Okay, so once you have that, you just want to get dy dx by itself. So then it just becomes an algebra problem. So I'm going to subtract over the 2x, which gives me 2y dy dx equals negative 2x. And then I'm going to divide by 2y, which means I get dy dx equals negative x over y. And that's the derivative with respect to x, like we said. Now, this one it said specifically find the slope of the circle at that point. So now I'm just going to come over here to the side, and I'm going to say dy dx at the point, I'm just going to put a little note down here, 3, negative 4 would be equal to negative 3 over negative 4. So all I did was take the x and the y and plug it in for the x and the y over there, which would simplify to 3/4. Now, if you recognize that, it says it's a circle centered at 0, 0 with a radius of 5. And that's a horrible example, but you know that that's 5 right there, and that's 5 right there, and it's centered hopefully at 0, 0 like it's supposed to be. If we go to the point 3, negative 4, so that's over 3 and down 4, that would be somewhere in this region right here. You can see that it has a positive slope, so at least my 3/4 slope matches that. Okay, here are your steps. So take a moment, write these down. First step is to just go ahead and start differentiating both sides of the equation with respect to x. And this is the part where if you take the derivative of anything else, so if you take the derivative of y, you need to tack on a dy dx. Okay? Collect the terms with dy dx on one side, factor out a dy dx, and then solve. So let's do a couple more examples so that you can get familiar with this. So here's a good one. This is an ellipse, For my BC friends, this would be a good time to try to complete the square and get it into the form of an ellipse so that you can see what it looks like. For anyone else, that is just not necessary. So we're going to go ahead and start taking the derivative. So the first one is super easy. The derivative of x squared is 2x minus. Now this is tricky. So I am going to implore you to please read this carefully because I know what you all want to do and it's wrong. If you read that middle term right there, that would say x times y, x times y. If you read that as x times y, then we do need a product rule. Okay, so product rule says the first times the derivative of the second. The derivative of y is 1 dy dx plus the derivative of the first, x, times the second, which is just y. Okay, plus the derivative of y squared is 2y with respect to x, means I tack on a dy dx, and the derivative of 7 is 0 because that's just a constant. Let's clean this up. So I've got 2x. I'm going to send that negative through. So minus x dy dx minus y, because I had to send that negative through to both of those terms, plus 2y dy dx equals 0. Okay, if you remember from the previous slide there, I then said collect all the terms with dy dx on one side and get everything else on the other side. So it really doesn't matter what you do here. I'm probably just going to subtract this 2x and add the y. So that will give me negative x dy dx plus 2y dy dx equals negative 2x plus y. Now I'm going to use GCF and factor out a dy dx. So that leaves me with dy dx times negative x plus 2y. Again, I just factor out dy dx equals negative 2x plus y. And then the very last thing that I have to do is just get dy dx by itself by dividing that over. So I've got dy dx equals negative 2x plus y. And then on the right, we're going to divide over that negative x plus 2y. Now you do have to be careful here because you could have a different version of this. So if I would have subtracted the dy dx's over the terms with dy dx's, I just have every opposite sign. So it is still right if every sign is opposite of the one that is given in the answer key. Now go back and read the question to make sure that we have answered it, which we have not. So we have to find the slope of the tangent and the normal. Okay, so I'm going to move up to the top. To find the tangent, we're going to do, just plug in the values there. So slope will equal negative 2 times negative 1 plus 2 all over negative negative 1, which is a positive 1, plus 2 times 2. Which is equal to 2 plus 2, which is 4, over 5. Hopefully I did that math right there because that was 2 plus 2. I think that's right. Don't forget that's in parentheses. It's just telling me right. And then to find the normal, it's the negative reciprocal. It's perpendicular. So therefore my slope would be negative 5 over 4 if I did all that work correct. Okay, so implicit's not horrible, hopefully. Hopefully you can see how that works. And all you need to do is just, like I said, take the derivative with respect to whenever you see a y, tack on a dy dx, something like that. So there actually is one more question. It's just not loading. So let me just go grab it from the slideshow. Hold on one second here. Sorry for, you can fast forward until I get this question. formatting is awful, but we will work with it. Okay, so this one's just slightly different because we're going to be taking the second derivative. So let me just write this again. So we've got 2x to the third minus 3y squared equals 8. And we want the second derivative. So don't get scared. The first thing we do is just take the derivative like we just talked about. So go ahead and start taking a derivative with respect to x. So this would be a good time to pause and try this one on your own. It's really pretty simple. Take the derivative. Whenever you see a y, take the derivative normal, but then tack on a dy dx. Get all your dy dx's together, everything else on the other side. And yeah, it's pretty simple. So pause, see if you can do it, and then check your answer in a moment. Okay, so now that you're back, let's see here. I got 6x squared minus 6y, and there's where I would put my dy dx, and then that's going to be equal to 0. So with a little bit of algebra, I believe we get dy dx is equal to x squared divided by y. Okay, now this had asked us to find the second derivative. So to find the second derivative, so the derivative of dy dx is d2y over dx squared. That's that notation. So that means second derivative. Now we have a fraction over there, so low d high. Before we do that, I always recommend that you just start with taking the derivative. So when you're in the process of doing the low d high, you don't have to think about, oh, what's that derivative? Because it's already done for you. Don't forget that the derivative of y is dy dx. Okay, so we start with low, which is y, d high, which is 2x, minus high, d low, all over low squared. And now the only catch is you can't leave a dy dx in your answer, so you have to sub back in. So 2xy minus x squared, and then dy dx was that original derivative that we found. So that would be x squared over y, and then that's all over y squared. And you can do some work if you want to clean it up, but if it's not multiple choice and they don't make you, then don't. Okay, so a couple of quick things. I'm going to go back to that slide. This is the important stuff. So you're going to differentiate both sides of the equation with respect to x. Remember, if you take the derivative of anything but the variable x, then you need to tack on a dy dx. You're going to collect all the terms on one side that have a dy dx. You're going to factor out the dy dx, and then you're going to solve for it. The only thing that's slightly different is if you need to take the second derivative, and then you just, after you take the first derivative, you take the second one and do not leave a dy dx in your answer. Substitute back in that first derivative. Okay, so like I said, that's the last rule for derivatives, and now we are going to practice with them.